Hello and welcome. European Medicines Agency or EMA has recently updated its Q&A documents related to the nitrosamine. And this updation has happened on 7th July 2023. So, in this particular Q&A document, the question number 10 is updated, which is related to the limits applied for nitrosamines in medicinal products. Now, what is the exact update? Now, there are two different approaches given by the EMA to establish the acceptable intake for any nitrosamine. The first one is very straightforward. You can conduct the carcinogenicity study, generate the carcinogenic data, understand the TD50, and based on the TD50, you can extrapolate a concentration which result a tumor in one species out of 1 lakh studied species until the lifespan, and that concentration can be called as an acceptable intake. But in case if you do not have this carcinogenic database, in that situation, the point number one can be used, that is the carcinogenic potency categorization approach or CPCA. Now, this particular approach is not very new to the industry and even to the regulators. The same approach has been used by the regulators to define the acceptable intake of the carcinogenic compound or nitrosamines, which is called as the SAR or structure activity relationship approach or a read across approach. You will find the mentioning of such approach into the EMA's nitrosamines guideline. So in this particular discussion, we will try to understand how this CPCA or carcinogenic potency categorization approach can be used to define the acceptable intake. In this particular video, we will talk about the 5 different categories of the nitrosamine compound and how to define these different categories for a given nitrosamine compound. We will also talk about some of the interesting examples how one can these categories be applied for actually setting the acceptable intake for nitrosamine. So please let me bring the presentation on the board now. So this particular questions and answer documents published by EMA has given the different potency categories. And before we go to the potency categories, we have to first understand in which category this particular nitrosamine compounds fall. So there is a important diagram you can see on the screen now. So what is the first question you need to ask? Does your nitrosamine have any hydrogen on its alpha carbon? I think you know the definition of alpha carbon. So the carbon which is just adjacent to the nitrogen is called as the alpha carbon. The carbon is called as the alpha carbon. So does there is a hydrogen present onto alpha carbon? See, if you remember in my last video, I talked about which functional groups, compounds or atoms influence the carcinogenic potency of the nitrosamine. And in the first statement, there is a very first point which talks about the presence of hydrogen on alpha carbon increases the carcinogenic potency of the nitrosamine. So let us first understand whether there is a hydrogen present onto the alpha carbon. So in case if there is no hydrogen present onto the alpha carbon, and you can see a example over here that, as I said earlier, that the carbon which is adjacent to the nitrogen is called as the alpha carbon. So is there a hydrogen present onto the alpha carbon in the given example? There is absence of alpha hydrogen. There is absence of hydrogen on alpha carbon. In that case, your compound actually falls under the potency category 5. And what is the limit for potency category 5 nitrosamine? It is the 1500 nanograms per day or 1.5 microgram per day. Now, what is this particular figure coming from? Now, you can relate to the TTC defined into the ICH M7R1 guideline, threshold of toxicological concern. So, in case if you want to avail this particular TTC approach, that limit is 1.5 micrograms per day. This is called as a highly conservative approach. And in case if you want to understand this particular approach, you can go through the ICH M7R1 guideline. But in case if your compound has a hydrogen present onto alpha carbon, you can see in the given structure that this is the alpha carbon, and each alpha carbon has a 3 hydrogen atoms present. So in case if there is a hydrogen present onto the alpha carbon, the next question you have to ask, does nitrosamine have more than one alpha hydrogen on one or both the sides of the nitroso N group? Nitrogen connected to the nitroso group. So you can easily understand there are more than one hydrogen on both the alpha carbons. So what happens if you say that, oh no, there is no more than one hydrogen present onto alpha carbon? I mean, there is only one hydrogen present onto each of the alpha carbon. You can see in the diagram over here. In that case, again, the potency category is given to the 5. And if the compound is categorized as the 5, then the acceptable intake is again 1500 nanograms per day or 1.5 micrograms per day, provided there is only one hydrogen present onto both of your alpha carbon. But there could be a second situation where there are more than one there are more than one hydrogen present onto your alpha carbon. In that case, we have to actually calculate this category, and we'll talk about those in the coming points. But for this particular situation, the question is, does your nitrosamine have a tertiary alpha carbon? And here is the diagram, talks about the tertiary alpha carbon. The tertiary alpha carbon is nothing but a carbon connected to 3 different carbon atoms. So this is the alpha carbon, and this alpha carbon is connected to the 3 carbon atoms. So it is called as a tertiary carbon now. So in case if it is a tertiary carbon, then again the potency or the category of this particular compound is going to be 5, and hence the acceptable intake of 1500 nanograms per day can be considered. But in case if this tertiary carbon is not available, I mean your alpha carbon is not a tertiary carbon, in that case you have to calculate the potency score. We will talk about the calculation of the potency score very soon. But what is the score now? Is the score equal to or greater than 4? Could be 5, 6, 7, 8, 9 or 10. But it should be at least 4 or greater than 4. If the answer is yes, then again the category of the compound is a 4 now. 4 or greater than 4 is classified under category 4, and the acceptable intake for such a compound is now 1500 nanograms per day or 1.5 micrograms per day. But in case if your potency score is not more than or equal to 4, then how much it is? Is it 3? If it is 3, then the acceptable intake is going to be 400 nanograms per day. Or is it greater, is it less than 3? How much it is? Is it 2? If it is 2, then it is 100 nanograms per day is going to be the acceptable intake. And if it is 1, then it is going to be 18 nanograms per day. So these are the 5 different categories and their respective limits. I hope this flowchart must have cleared your understanding about the categories and related to their acceptable intake. So how these 5 different potency categories are defined and their limits have been discussed in the few of the previous slides. So the potency category 1 means what? It is the most potent nitrosamine, isn't it? And the recommended acceptable intake you can see is the 18 nanograms per day. So this particular limit is defined from the class specific TTC. You must have seen this 18 nanograms per day acceptable intake into the EMA's nitrosamines guideline. In case if there is no carcinogenic data available, the guideline talks about adopting the 18 nanograms per day limit, which is the nitrosamine class specific TTC, and TTC stands for the threshold of toxicological concern. But in case if you see that your compound is following under the potency category number 2, then the 100 nanograms per day can be the recommended acceptable intake. And this particular recommendation comes from two important nitrosamines. One is NDMA and second one is NNK. In case if your compound falls under the potency category number 3, then the recommended acceptable intake can be about 400 nanograms, which is almost 4 times of the category 2. And category 4 onwards, the acceptable intake is going to become 1500 nanograms per day. And same is applicable for the category 5 too. So it's very important part of the discussion now, calculating the potency score. So what is the calculation formula to define the potency score? And here it is on the screen. So potency score is the summation of alpha hydrogen score, deactivating feature score, and activating feature score. Okay, so don't get confused at this particular time. We will talk about all the details. So alpha hydrogen score means what? It is going to understand, you need to understand how many hydrogens are present onto the alpha carbon. Is there a presence of hydrogen on alpha carbon, or is there an absence of hydrogen on alpha carbon? We will talk about some of the examples on defining the alpha hydrogen score. Now there are deactivating feature score. If you don't understand the deactivating score means what? It is actually going to decrease the potency of your nitrosamine. Now there are certain functional groups like present of hydroxyl functional groups on beta carbon reduces the potency of the nitrosamine. That is deactivating the potency of the nitrosamine. Deactivating stands for reducing the potency of the nitrosamine. So what are those functional groups? As I explained, the hydroxyl functional groups present onto the beta carbon is a deactivating feature. Carboxylic acid functional group present at any part of the molecule is also a deactivating feature. So there are certain deactivating features. So you have to calculate those deactivating feature score, and that will help you to define the potency. And the third term is the activating feature score. Activating feature score means what? Now which functional groups is going to actually increase the potency of this particular nitrosamine? Like presence of aryl functional groups onto the alpha carbon enhances the potency of the nitrosamine. It makes the nitrosamine compound more potent. So we will try to understand these three important terms: alpha hydrogen score, the activating feature score, and the activating feature score. So this particular Q&A guidance document has given the guidance on defining the alpha hydrogen score. So what you have to do, you have to simply count the hydrogen atoms present on each alpha carbon. You have to calculate this hydrogen present on both the alpha carbons. And the lowest count has to be given first, followed by the next one. So here is the table which determines the alpha hydrogen score. So now here is the compound. If you look on the first row, how many hydrogens are present onto this benzene alpha carbon, which is connected to the nitrogen? There is none, isn't it? So you have to give the lowest count first. So 0 comes first, and then comma. There is another alpha carbon also. And how many hydrogens are present onto that? There are 2 hydrogens present onto the another alpha carbon. So 0, 2. And guidance has given that in case of such a situation, your alpha hydrogen score becomes 3. In case of 0, 3, the alpha hydrogen score become 2. And you can understand the another combinations and what is the related alpha hydrogen score. So based on to this particular table, you can define the alpha hydrogen score. The second important point is what now? The deactivating feature score. That is the second term into our calculation formula. So what is going to deactivate or which functional groups actually decreases the carcinogenic potency of the compound. Here is the example. Carboxylic acid group present anywhere in the molecule is going to decrease the potency of the compound, and hence comes with the plus 3. Now plus 3 means what? It's going to increase the overall potency category. And the more is the potency category, less is the potency of the nitrosamines. You must have seen the 1 to 5 categories. 1 stand for highly potent nitrosamines and category 5 stand for the least potent nitrosamine. So this plus 3 is going to increase the potency score, going to make our nitrosamine least potent. Again, the presence of a pyrrolidine ring is also going to decrease the potency, and the plus 3 is the number. The N-nitroso group in the 6-membered ring containing at least one sulfur atom is also going to deactivate or decrease the potency, and the plus 3 is the deactivating score. Nitroso group in 5 or 6-membered ring is also going to help us in decreasing the potency of the nitrosamine, and plus 2 is the score. N-nitroso group in morphylene ring is also going to help us in decreasing the potency of the nitrosamine, and plus 1 is the score. N-nitroso group in 7-membered ring is also going to help us in decreasing the potency, and plus 1 is the score. More is the chain length, less will be the potency of the nitrosamine, and plus 1 is the score. Electron withdrawing groups bonded to alpha carbon on only one side of nitroso group is also going to help us in decreasing the potency, and plus 1 is the score. Electron withdrawing groups bonded to alpha carbon on both sides of N-nitroso group is also going to help us in decreasing the potency, and plus 2 is the score. Similarly, the hydroxyl group bonded to beta carbon and hydroxyl group bonded to beta carbon may be present on one side or both the sides, can certainly also helps in decreasing the score. If it is on only one side, plus 1 is the score, but if it is present onto both the sides of the beta carbon, then the plus 2 is the score. So it's about the deactivating feature. Which functional groups are going to help us in decreasing the potency of this particular nitrosamine. So the third term in the calculation of potency category is the activating features. So what are the functional groups that can activate, means that can increase the potency of the nitrosamine? So there are two important functional groups mentioned into the guideline. The first one is aryl group and the second one is methyl group. But the aryl group present onto the alpha carbon is going to increase the potency, and here is the activation score, which is -1. -1 means what? It is going to actually reduce the potency score, and we all know that the lower is the potency score, higher is the carcinogenic potency. Similarly, the methyl group present onto the beta carbon is going to also decrease the increase the potency of the nitrosamine, and -1 is the activation score. So we try to understand the calculation of the alpha hydrogen score, deactivation feature score, and the activation feature score. So by summing all together, one can calculate the potency score. So by taking some examples, we will try to understand how this can be done practically. The first example is N-nitrosophyllodipine. And here is the structure of N-nitrosophyllodipine. You can see that there are no presence of hydrogen onto the alpha carbon. And if there are no presence of hydrogen on alpha carbon, the compound can be categorized as the category 5. The potency category of the compound is going to be category 5. So the second example is N-nitroso-enalapril. And here is the structure of N-nitroso-enalapril. So how many hydrogens present onto the alpha carbon? So there is one hydrogen present on each of the alpha carbon. And what is the category of this now? If there is only one hydrogen present onto alpha carbon, it again falls under the potency category 5, and acceptable intake is going to be 1500 nanograms per day. The third example is N-nitrosoketamine. Here is the structure of N-nitrosoketamine. So the important feature is the presence of tertiary alpha carbon and the presence of hydrogens onto the alpha carbon. But if you remember our flow chart, you must realize that if there is a tertiary carbon uh, connected to the, I mean, if there is a alpha carbon which is a tertiary carbon, in that case, your compound straightforward falls under the potency category 5, and you can avail the acceptable intake of 1500 nanograms per day. The fourth example is N-nitrosonebivolol, and here is the structure of N-nitrosonebivolol. So how many hydrogens on alpha carbon? So this is the alpha carbon, isn't it? You can see near the cursor. And how many hydrogens are present there? Two hydrogens. And again here is the alpha carbon containing two hydrogens. So if there is a two hydrogens on each alpha carbon, the score of the alpha hydrogen becomes +1. Is there a hydroxyl group present on the both the sides of beta carbon? I have not mentioned about this beta carbon, but yes. So there is a presence of hydroxyl group on the beta carbon is going to help us in reducing the potency of our nitrosamines, and that is going to help us actually in increasing the score of the category. So +2 for the presence of hydroxyl group onto the beta carbon. What is the chain length? The chain length is greater than 5. 1, 2, 3, 4, 5, 6, and 7, isn't it? And if there is a bigger chain, more members present into the chain, actually our score get increased or potency gets decreased. So +1 is for the chain length greater than 5. So what is the potency score? 1 plus 2 plus 1 equal to 4. So the potency category is equal to 4 now, as the score is not greater than 4. And the potency category 4 belongs to an acceptable intake of 1500 nanograms per day. So this is the acceptable intake recommended for potency category 4. The next example is N-nitrosomeropenem. So this is the structure of compound. I'm so sorry for the blurred figure. But you can see that there are two alpha hydrogens on one side and one alpha hydrogen on another side. So the hydrogen on alpha carbon is having a score of +3. There is a carboxylic acid functional group present into compound, and that is going to help us to actually reduce the potency or increase the potency score. That is +3 can be added for the carboxylic acid. You can see over here. This is the carboxylic acid functional group. Then the N-nitroso group in pyrrolidine. I'm so sorry for the spelling mistake. It should be pyrrolidine, not pyrrolidone. So here is the pyrrolidine ring, isn't it? And that is going to actually help us in reducing the potency, and +3 is the score. Is there electron withdrawing group connected to the alpha carbon? Now here is the electron withdrawing group connected to the alpha carbon, isn't it? CONH2 NR2 means it is a amide functional group, which is a electron withdrawing functional group. And this is certainly going to help us in reducing the potency of the carcinogenic compound or increasing the score of the carcinogenic compound by +1. So what is the total score now? The total score is going to be 10. As it is greater than 10, you have to uh, see the potency category as a 4 now. You can give the potency category as a 4 if the score is greater than 4 or equal to 4. What is the acceptable intake? In that case, it is recommended to be 1500 nanograms per day. Now, why not category 5? Because there is an absence of hydrogen on alpha carbon. Category 5 is generally given for the compound where there is no hydrogen present onto the alpha carbon. Example number 6, N-nitroso-desloratadine. This is the structure. The hydrogen score, alpha hydrogen score is +1, as there are two hydrogens on two alpha carbons. N-nitroso group present on the 6-membered ring. This is a 6-membered ring, so plus 2 for that. So total score is 1 plus 2 equal to 3. So potency category equal to 3 and the acceptable intake is 400 nanograms per day. Then sertraline, sorry. This is the compound where you have the hydrogen present onto the alpha carbon. So alpha hydrogen score is plus 3. Aryl group bonded to alpha carbon is going to actually make the compound little more potent. And the minus 1 is the score. This is the aryl compound. Benzene ring connected to this particular alpha carbon. The total score is 3 minus 1, 2. So this comes under the potency category 2 and the recommended acceptable intake is 100 nanograms per day. N-nitroso lorcaserin. Okay, so this is the compound where we have two hydrogens present on each of the alpha carbon. So plus 1 is the alpha hydrogen score. It's present onto the 7-membered ring. This nitrogen is present inside the 7-member ring. So plus 1 for that. Methyl group bonded to beta carbon actually makes the compound more potent. So minus 1 for that. So this is the methyl compound, methyl group, right? And that has made the minus 1 in the score. So the total score is 1 plus 1 minus 1 gives the 1. So this comes under the potency category 1, which is having the recommended acceptable intake of 18 nanograms per day. So this is all about the different examples on calculating the potency category and the score. Thank you so much.